Hey there, let's cover section 2.2. This might be made in two parts because this is a substantial amount of information, and I think I might have to make this into two parts. Otherwise, no one's going to want to watch this. I don't even want to make it if it's this long. All right, maybe we'll get through as much as I can, and then if I need to take a break and make a second part, I will. Just a heads up. Okay. Linear equation and one variable. So we're just solving for x, and the coefficient of x can't be 0 because then you wouldn't be solving for x. All right, so in 2x plus 7 equals 19, solving for x, all we're going to do is start by getting rid of the 7, subtracting 7, subtracting 7 from both sides. And we get 2x is equal to 12. And then 2 is attached to x, so by multiplication, so we have to divide both sides by 2. And therefore, x is equal to 6. All righty. The next one. Okay, I see where this can be an issue. Be careful with distribution. So the first thing we're going to do is distribute this 4 over the binomial x minus 3. So that's just going to be 4 times x and 4 times negative 3, which is 4x minus 12. And then plus 12 is equal to 15. And then the negative 5 gets distributed over the x plus 6. So that's negative 5x. And negative 5 times 6 is negative 30. Now, what we're going to do here is solve for x. So I'm going to start by combining like terms. I get 4x over here. These are gone. Negative 12 plus 12 is 0. Equals, well, we've got negative 5x and then minus 15. That's 15 minus 30 is negative 15. So I'm going to start by bringing over the negative 5x. And we get 9x is equal to negative 15. And the last step here is divide both sides by 9. And x equals negative 15 over 9. Or you can reduce that to negative 5 over 3. You can make it a mixed number. You can make it a decimal. I spoke about this in class. I don't care how you present it, but do not leave it in this form. Please ensure that if you do leave it in fractional form, that you at least reduce it. Okay. All right. Example 3. So we've got 7 over 2x minus 5 over 3x equals 22 over 3. So the thing I ask in class is who likes fractions, and there are those sickos out there that do, including me. But for the rest of most folks, they do not. So what you need to do is find what is the lowest term here, the least amount of terms you need, lowest common denominator, is what you need to be looking here for. So I'm going to take the 2x, the 3x, and the 3. I'll show you what I do. And ensure that everything is represented. And then I'll show you how we can get rid of the fractions, but only if there's an equal sign. It has to be an equation, not an expression. All right. So we need a 2. So we need the 2. We need an x. We need a 3. And then the other 2 are already represented, an x and a 3. So 2 times 3 is 6. 6 times x is 6x. So what I'm going to do is multiply each term that I have here by 6x. Equals 6x, 22 over 3. All right, now this is how we get rid of the fractions. We're going to reduce. 6 divided by 2 is 3. The x's cancel each other out. X divided by x is just 1. So I have 3 times 7. There's the first term. Now let's go to the next one. It's going to be a negative. 6 divided by 3 is 2. And the x's cancel each other out. So that's 2 times 5. Equals 6 divided by 3, 2. So 2x times 22. All right, combine. 3 times 7 is 21. Negative 10 equals 2 times 22 is 44x. All right, 21 minus 10 is just what? 11 equals 44x. Divide both sides by 44. And x equals 11 over 44, or that reduces both of them by 11. And so that's going to give us 1/4. The other thing you can give me is 0.25. Same thing. Okay. All right. So there's our x. Rational equations contain at least one rational expression where the variable appears in at least one of the denominators. Sorry, y'all, been a long day. Example 4. Oh, this is just like the last one. Okay, so if it's just like the last one, I want you to pause the video, attempt this on your own, and then come back and see how I did it. So pause. I'm going to keep going. So I see that we need an x, a 2, and this one already has 2 and x. So 2x is what we're going to be multiplying each one of these by. And I'm just going to write it like this, okay? Because I can reduce this way as well. You can do it different ways each time once you get comfortable. So 2x, the x's are going to cross out. We get 2 times 2, which is 4. The next one is 2. We got a negative here. 2 divided by 2 is 1. So we have x times 3 equals. And then we have 2 divided by 2 and x divided by x. So we just end up with 7. All right. Solving for x. You take 4 to the other side. Negative 3x is equal to 3. Divide both sides by negative 3. And x equals negative 1. Boom. Okay. Going to example 5. Hope if you had any questions on that one, once you attempt to do it yourself, let me know. Same thing for this one. This is just like it as well. So we're going to use, oh, hold on one second. If I can get this to pause. Okay, sorry about that. Example 5. I want you to do the same thing we did before. Make sure that you attempt it and then come back and watch how I do it, because it's at this point that you should be able to start working through this. All right, so they have an x, a 10, and a 4x. So let's see what we can figure out. I'm just going to break these down by primes. I think that's easier. So we need x, we need a 10, which breaks down to a 2 and a 5, and then a 4, which breaks down into a 2 and a 2, and then another x. So we've got one x, so we don't need this one. We've got 1, 2, so we don't need this one. And then we need these two numbers here as well. So we need 10, we need 20x is what we're going to multiply each one of these by. You could also multiply by the entire thing, 10 times 4x squared, but that would be just not fun. So I'm going to come through here and multiply by 20x. All right, 20x times 20x times 20x. So 20x divided by x, the x's are gone. So 20 times 1 equals, all right, now we have 20 divided by 10. Well, that's going to give us 2. So 2x times 1 is 2x. And then the last one, 20 divided by 4 is going to be 5. And the x's are gone. So 5 times 3, negative 5 times 3. All right, so we have 20 equals 2x minus 15. I'm going to take 15 over to the other side. And we get 35 is equal to 2x. Divide both sides by 2. And we get x is equal to, looks like 17.5 or 17 and a half, or just 35 over 2. So I'm just going to go ahead and write 17.5 to make some of y'all happy. All right. And that is it for that one. All right. Solving the following rational equations and state the excluded values. Okay. So let's just solve. I'm going to do the same thing. I'm just going to put a here. 3 divided by x minus 6 is equal to 5 over x. Now, the common denominator here would be x minus 6. So I'm going to multiply both terms by x minus 6, and that's going to be 3 over x minus 6 equals x minus 6 times 5 over x. Notice this is what it originally was. So now the x minus 6's are gone on the left, and we've got x times 3 is 3x. The x's are gone here, and we're left equal to 5x minus 6. 5 times x minus 6. You have to distribute that 5 over the x minus 6. So we get 3x is equal to 5x minus 30. I'm going to take the 5x to the other side. I get negative 2x is equal to negative 30. Divide both sides by negative 2. And I get x is equal to 15. All right. I'm going to do B, but not C, because they're going to be the same. All right. And the answers are in the book as well. So let's look at B real quick. And that is x over x minus 3 equals 5 over x minus 3 minus 1/2. So the LCD on this one is 2x minus 3. And I'm just going to write it up here because I'm running out of space. So 2x minus 3. Well, the x minus 3's are going to cancel out when I multiply through, and I'm left with 2 and x. So 2x is equal to, now let's look at the next term. The x minus 3's cancel out again, and we're left with just 2 times 5. And then the last one, the 2's are going to cancel out, and we're left with x minus 3 times 1. All right, so we've got 2x equals 10. Now distribute that negative 1 over the binomial, and you get negative x plus 3. We'll take the x to the other side and combine like terms. So plus x, we get 3x is equal to 10 plus 3, which is 13. Divide both sides by 3, and x equals 13 over 3. All right. Let's go to the next one. Solving the rational equation with factor denominators and stating excluded values. So notice they said factoring the denominators. So these are already factored. There's nothing you can do. But the x squared minus 1 is a difference of 2 squares. So we can just break that bad boy up into x minus 1, x plus 1. All right, so to find our LCD, it's going to be x plus 1 and x minus 1. Plus 1, x minus 1. So I'm going to multiply it to each one of these. So I'm going to rewrite this real quick. 2 over x plus 1 minus 1 over x minus 1 equals 2x over x plus 1, x minus 1. All right. So multiplying by this to each one of these terms, the x plus 1's are going to cancel out. I'm left with 2 times x minus 1. Minus, the x minus 1's are going to cancel out, and I'm left with x plus 1 equals, both x plus 1 and x minus 1 are gone because they cancel each other out, and I'm left with just 2x. All right, I'm going to distribute my 2 over my binomial. You're okay, Charlie. We'll talk more. And a 2 times negative 1 is a negative 2. Distribute your negative over your binomial. Remember, there's nothing out front. There's an assumed 1. So negative x minus 1 equals 2x. All right, combining like terms, 2x minus x is just x. Negative 2 minus 1 is negative 3 equals 2x. I'm going to bring my x to the other side. And I get negative 3 is equal to x. There we go. Boom. All right, we have gotten to the slip line. I'm going to stop here and push this video out, and then I'll come back and I'll record a secondary video for y'all so that you can have everything.